Dr. Dhamejani sir. Dr. Dhamejani sir has done his BSc in 1969 from Agra University, MS in Mechanical Engineering in 1974 from People's Friendship University, Moscow, Russia, and his PhD in Mechanical Engineering in 1988 from IIT Bombay. Sir actually worked with the Vehicle Research Development Established, DRDO, Ahmednagar, Pune, on various post cadre from September 1974. He's worked on grade like pool officer for the diesel loco Varanasi, SSO second R&D defense engines, scientist C and F on R&D on defense engine, as a scientist F for the director of VRD, for the scientist G for the director of VRD from July 2005 to November 2019. Sir has done the various works on various cadre in the R&D department of the VRD. After the retirement, Sir's work has also going on. His work as a visiting professor on the various institute like DIAT, Pune. He is also worked as a professor and principal on Jai Hind College of Engineering, Pune. I am happy to inform you that Sir also worked with the Veermata Jijabai Technological Institute in a mechanical engineering department as an adjunct faculty. Sir has various membership for the professional societies and the institutions, chairman of the local center of IEI Kolkata, life member of Institute of Automobile Engineers Chennai, fellow institutions of engineers Kolkata, member SAE India, distinguished visiting professor for INAE. Sir has got the awards and honors for the DRDO Scientist of the Year Award 2005 for work on two-stroke engines. Also Technology Spin-Off Award 2017 for work on bulletproof vehicles. Before just 2-3 minutes, when we are talking with us, sir also informed that sir started working on the NPTIL and also for the defense technology course started by or initiated by the Gujarat University. So such a distinguished faculty or the scientist we have with us on today for delivering the session on technologies in electric and hybrid vehicles. Thank you very much, sir, for accepting my our invitation, and please share your knowledge and the experience with the work with us. Thank you, sir.
Thank you, Professor Vijay, for introducing me. Shall I start my presentation?
Yes, sir, you can start.
You can hear me?
Yes, sir. Yes, sir.
Okay. So,
yes, sir. Yes, sir.
Can you see the slides?
No, sir. Please present it from the present now.
Now, present now.
Yeah, then a tab that window that you have opened already for that slide, PPT slide.
So now can you see?
No, sir.
No, sir.
So present now I have turned on.
Yeah.
There is after present now. Where do I go?
In present now there is another tab open, and that is window tab. Such kind of things are there.
A window. Okay.
Window.
I say there is? Okay. I go to window.
Yeah.
Now then I share.
Yeah. No, sir. That first select that in window. Okay. You will see that there is one PPT that you already opened it.
Okay.
Yeah. Select now that PPT and then share.
Okay. Select that PPT and then share.
Yeah.
So now I don't see share if I am. If I.
Okay, you can directly choose like that. Present now. Yes. Now it is going on, sir.
It is going on. Okay.
Yes, sir. But we are not able to see that PPT.
Why you are not able to see? How do I make it? Can you see?
Just wait, sir. Sir, any other windows are open on your PPT? Sorry,
There is
PC?
there are no. I don't think except for the. There is no other window. Okay, rediff is open. Yes.
You just please do again. By stop sharing, you just go into the present now and then select that PPT, and then, sir, there should be that
Shall I
sharing.
say present now?
Yeah,
Present now a window. Then
yes,
I put on this PPT.
yeah.
Now can you see?
No, then after that you have to choose share now, sharing.
Okay. Okay. But when I switch on my window PPT, then I don't see the share.
No, so don't switch on, just select it in that window.
Is it okay?
Not visible.
PPT is not seen.
Any professor, are you able to see?
No, Vijay sir.
Yes. What happened?
No, sir.
No,
Uh,
actually, if the
Chetan,
PPT is
sir.
there, then see the sir is sharing the screen. If the PPT is there, then in that case he can minimize this window and the straightway he can show the PPT also. So we are able to see the PPT also. If the PPT is open in the other window.
Chetan, sir, have you opened the presentation, the PPT? Have you opened it? Or it is
Yes. Yes.
yet
It
to
is
open?
my. It is on my screen. It is there.
So you must have minimized it.
No.
So
It is.
instead of that, if they choose the entire screen, then it is visible to all.
Now I have chosen the entire screen, and I see the at the bottom. Stop sharing. Hide to meet google.com is sharing a window I see, and there is a logo stop sharing and hide. So shall I put on a stop sharing and see the effect?
Sir, you can do one thing. You just stop sharing and you minimize your PPT, and then you do this. You minimize the PPT.
Okay, now
Then
I
go to the present now.
okay, present now.
Now you choose from window.
Window, okay, a window or entire screen I choose.
No, sir,
Entire
no, just
screen you
window. In that window, just select on that PPT,
In
and
this
then
in window there is no PPT, na? In this.
no, sir, when you are minimizing, it will be there.
I minimize PPT.
Yeah.
Shall I raise it now?
No, now you go to the present now. Select a window.
Present now is now not seen. Now this window I see on my screen, share an application window. And shall I say share?
Okay, you do. Sir, can you send me? I will share it.
What do I send you?
I can share it.
You can share it.
Yeah.
can mail him. You can mail him.
Presentation.
Yeah.
I don't know whether I'll be able to mail it.
Yes. Okay, okay. Just you tried it. Maybe. Yeah. Now it is coming, I think. Hello.
Hello.
Yes. Is there any blank slide, sir?
There's a white screen you can see.
Yeah, white screen is there.
No, I am seeing my PPT on my laptop.
Sir, you just off that PPT and again you try.
So choosing the entire screen will work, I guess,
No, they are
rather
doing like that,
than
I
choosing
think.
the window.
Now you are presenting. Should I say you are presenting on?
But we are not able to see anything, sir.
So,
Sir, earlier you did not use this Google platform. Okay.
Hello, here entire this screen,
Ah,
entire screen. I think that will work. Means whatever the window he will open, sir will open, so that will be
oh,
visible to everybody.
okay, okay. Sir, please wait. He is joining.
can you hear me?
Yes, sir. Yes, sir. You try again, sir. Maybe sometimes it happens, or you try again.
Shall I open my PPT or go to
Yes, sir.
present?
Yeah, yeah.
Go to present now first.
Yes.
Okay. Can you see something?
No, sir. Present now, and then you can choose entire screen also by opening that PPT.
I see share an application window on the
Yes,
top.
yes.
And then I see in the bottom share and cancel. So
Yes, yes. Now you choose. Now you choose that PPT and then share.
But then I'll not be able to see when PPT I'm opening. I'm not able to see share.
How this is happening?
I'm opening PPT, then I'm not able to see share. I
No,
minimize PPT, then I'm able to see share and cancel.
yeah, that will be okay, na, sir.
No, what
You,
do I
you
do?
then
When I
yes,
share
yeah.
and I open my PPT, you are not able to see my PPT.
Now I
My,
am not able.
No, sir.
so, so how do I share then? I've closed that present now. Then there is a small window, share an application window.
So in that window there, you are able to see that PPT.
No, I am not able to see PPT. And when I am
Okay. Just you do one thing. Now cancel that.
okay, can
Just open the PPT.
open the PPT.
Now minimize. Now minimize it.
Now minimized.
And now again go to the present now.
I am now at the present now.
Now are you able
Shall I go to window? A window or
yes. Yeah, window.
I have gone to window.
Yeah, now you are able.
Now there is a thing. Now there is a window. Now there is a window. So
Yes.
shall I open my PPT and then share?
Not open. Just just click on that and then share.
Click on this. Okay.
Now share.
Share.
Yes.
Then I switch on my.
No, you don't do anything.
Then how do I? Then it remains minimized.
क्यों हो रहा है ऐसा?
You are presenting. No.
Okay, now you do another
sir.
thing that the other people are advising us.
Hello,
You just
hello.
open that and
Vijay
share
sir,
the
shall
entire
I
screen.
intervene?
Yes, of course.
Chetan sir,
Yes, sir.
you please stop. You stop the presentation, sir. There's a right
Stop.
on the right bottom corner. You will see stop. You are presenting. You stop the presentation.
Yes, stop sharing. I am seeing.
Yeah, stop presenting. Yeah. Now the presentation must be open somewhere on your tab. So what you do, sir, on the right bottom corner, you will find a tab called Present Now.
Okay.
You click on
Shall
the
I
Present
click?
Now. You click over there.
Yes.
You'll find three options: your entire
Yes.
screen, a window, and a tab.
Right.
You click on
Then
the first option, your entire screen.
okay. Clicked
Okay.
entire screen.
Yeah.
Then
So your PPT, you must have minimized it somewhere.
yeah. Shall I raise it now? Shall I
So you
put it? Shall I?
yes, you put it on, sir. You put it on.
I put it on.
Just share and then put it on.
No, okay. First I share it and then put it on.
Yes, sir. You
Share it
first share
Yes,
it
sir.
and then you put it on.
Okay. Can you see?
So it's still not working, sir.
Not working.
Yeah. Now, so
Now it is
now we are
visible.
able.
Yes, sir. Yes, sir. It is working.
It's
Yeah,
okay.
now full screen, sir. Full screen.
Yeah,
Full
thank you,
screen.
Gaunde.
You can click on F5. Yeah, you can full screen.
Thank you, Bandarkar sir. Thank you, Gaunde sir.
Can you see now?
Yes, sir. Yes, sir.
Yes, sir. It
Shall I?
is visible.
Yes, sir. You
Shall
can
I?
start now.
Okay. Thank you, sir. Thank you. Sorry for inconvenience. I'll start
It's okay,
my
sir. It's okay.
presentation.
No
As you
problem.
see, my topic is in electric and hybrid vehicles. This my profile has already been read. Now I introduce the subject. I have worked on hybrid vehicles. So initially I'll present you the whatever is available with the trade. In my time, actually, this work is about of 2008 and 9, and we were doing projects on hybrid vehicles at VRD Ahmednagar. I divided my presentation in 4 parts. That is, I'll be covering the history of hybrid cars, technologies in hybrid cars, technologies developed by DRDO for different vehicles, and industry readiness with the technologies. And finally, I'll conclude. Starting with the history, a hybrid vehicle we know is combines 2 or more sources of power. Examples could be moped, where gasoline engine is there with pedal power. In locomotive also we have diesel and electric, where that is a hybrid. And in submarines also diesel or nuclear plus electric. So these are all hybrid use of the energy. Similarly, a hybrid in automobile combines the power of a gasoline engine and an electric motor. Thus, hybrid is a compromise. It significantly improves the mileage of the conventional car while drastically reducing the emission. It practically overcomes the shortcomings of the electric vehicle. Thus, by use of electric power, we can downsize the engine. Diesel or gasoline, whatever engine we are using, it can be of a smaller size, and the balance power can be given by the electrical. That is the reason why hybrid cars. Hybrid cars help us to reduce tailpipe emission of both, that is carbon monoxide and carbon dioxide. That improves our mileage. Both these two are interlinked, that is carbon monoxide and dioxide and mileage. Both they are interlinked, and practically it is possible to get zero emission vehicle by use of a hybrid vehicle. In US, there is a corporate average fuel economy standard as per which you can have average mileage of a car sold by a company should be at least 11.75 kilometers per liter. That means that for every one car with a mileage of 25 kilometers per liter, the car maker can sell 4 big cars with a mileage of 8.5 kilometers per liter. So that is the advantage of hybrid. And what a customer sees in a car is car should be at least running for 400 kilometers between the refueling. It should be refueled quickly and easily, and it should keep up with the other traffic on the road. While a gasoline car meets the above, it gives good mileage and causes a lot of pollution. Often the desire for quick acceleration leads to installation of bigger engines and consequently lower mileage. Problems with the electric cars are, while the electric car is non-polluting, it can go only 80 to 120 kilometers between charging. It is also very slow and inconvenient to recharge the batteries. How do we size a car for how do we size an engine for a car? While driving on highway, the engine has to provide power to overcome the aerodynamic drag caused by the pushing the car through the air, overcome all of the friction in the car's components such as the tires, transmission, axles and brakes, provide power for accessories like air conditioning, power steering and headlights. For most cars cruising at about 80 to 100 kilometers per hour, doing all this requires less than 20 horsepower. I'll be a little fast to cover up the whole thing, so please bear with me. Hybrid cars, but modern cars engine have a typical rating of 90 to 135 horsepower, and most of the excess power is provided for swift acceleration and pickup. In a hybrid, the gasoline engine is smaller, but the electric motor provides the additional thrust when needed. During braking or going downhill, the kinetic energy is recovered to charge the battery, and the engine is shut off completely during stops, such as traffic lights. Coming back to hybrid cars, we know that there are two sources of propulsion, that is gasoline engine and electric motor. Two sources of energy storage are required for two systems. Fuel tank is required for gasoline and electric motor needs batteries. Both can independently and simultaneously power the transmission. And in hybrid car, we can have different systems of sharing power. It can be in series. Power from the engine and motor can be fed to the transmission. It can be in series. And examples are Honda Insight car and Honda Civic car. It can also be in parallel, and it can also be in series parallel hybrid, where there is a power split device that splits the power being drawn from the engine as well as motor and being fed to the transmission. And there is a generator for charging the batteries and running the motor. This is the power split device. You see here is a planetary system. Sun gear connects to generator. Planetary gears connect to planetary carrier, and ring gear connects to motor and differential. Planetary carrier is connected to engine. So this is a power split device used on car, that is Honda Prius. Thus the components in a hybrid car are gasoline engine of a smaller size. It may even have less number of cylinders. Torque pulsations is smoothened by electric motor, particularly in full hybrid. We'll see there are two modes of hybrid. In one case, 15% power comes from the electric side, and other case, it is more than 40% of electrical power. New technologies for reduced emission and increased efficiency can be introduced, like lambda sensor, catalytic converter, etc., on this kind of gasoline engine. And then we have fuel tank, which is the main energy storage. That is 1 liter of gasoline stores as much as 120 kg of batteries. So this is the comparison between gasoline and batteries capacity with respect to storage of fuel. Other components are electric motor, sophisticated permanent magnet AC synchronous type, advanced electronic controls, can run as motor to start and accelerate the vehicle, can also run as generator to brake the vehicle and return the energy to the battery. Generator only on series or series parallel hybrids to supply electrical power for the motor. No separate starter alternator required. If we see the technologies in batteries, we have different types of batteries: lead acid type, nickel cadmium type, nickel molybdenum hydride side, and lithium ion batteries. They have different storage capacity of specific energy, starting from 35 watt-hour per kg to 120 watt-hour per kg, and specific power being 200 watt to 300 watt per kg, and the life cycle goes from 450 hours to 1200 hours. So these are the different technologies suitable for hybrid cars. Other components are batteries, as we have seen different types, electrical energy storage device, and can supply energy during normal running as well as receive energy during braking. Special type to suit rapid charging and deep discharging. Does not need external charging at all, except for plug-in hybrid. Transmission, similar to conventional cars in parallel hybrids, that is Honda Civic and Honda Insight, and complex in case of Toyota Prius. And complex means series, parallel series. Hybrid electric vehicles are classified depending on the share of the electric motor versus gasoline engine, ability to run independently on batteries, running range on batteries alone, peak power capability of the electric motor, possibility of externally charging the batteries. Thus, there was a roadmap in our time how to convert gasoline engine to operate on hybrid mode, starting with frequent on-off electric braking. Energy braking energy can be used for generating electricity for charging the batteries. Then it goes to operating on electric alone, and then further recharging from the mains at every 20 miles on electric mode. This was the roadmap which we were contemplating it will materialize, but I have not seen it materializing even today. Although a lot of work is going on. Further, hybrid electric vehicle evolution. There were two types. Initially, mild hybrid uses only 15% of power from electric. During shutoff of the engine during stops in traffic, energy is used for regeneration. And gasoline engine is of a smaller size because 15% is coming from electricity side. And there is a possibility of parallel hybrid also in both these cars, that is Honda Insight and Honda Hybrid, Honda Civic. So this is Honda Civic, this is Honda Insight, and full hybrid is where when we use more than 40% of the peak power of engine from the electricity, we call it full hybrid. And even when we shut off the engine during frequent stops, we use that energy for charging the batteries. We call it regenerative braking. We use a smaller gasoline engine, series or series parallel type, and can run on electric power alone. Toyota Prius is a full hybrid example shown here. This is a full hybrid vehicle. There is another option with Daimler Chrysler also, where more than 40% of the peak power is used from electricity in hybrid mode. The engine shut off again during frequent stops. Regenerative braking is used. A smaller gasoline engine is used, and power split can be in series or parallel type, and it can run on electric power only. And plug-in charging is also possible from utility mains. This is the example of Daimler Chrysler, and this vehicle is very expensive, although it is available. When a customer looks for an hybrid vehicle, he compares various parameters before deciding on the purchase of the car, like fuel cost savings. 89% of the people think of fuel cost savings by use of hybrid car. 87% think of reduced maintenance due to hybrid mode. 50% expect longer range. 83% of the people think of more than 50% range should go up. And 73% people look for fully charged battery as the first option, first preference. And better handling and weight distribution is seen by 71% people. And reduced pollution, 66%. Better handling and lower CG, 66%. And quietness, 61% people prefer. Reduced dependency on oil, 60%. And less vibration and fatigue, also 60%. So this is the preference of people when they purchase a hybrid vehicle. If we compare the parameters of hybrid cars, I have shown you inside Civic Hybrid and Prius. You see here Civic Hybrid inside and Civic Hybrid They use only 15% of the electric power, and their size of the engine is less from 1000 cc, whereas in Prius, where 40% of the power comes from the electricity, engine size is bigger because it needs more power, much more power. Here in this case, only 3 cylinders are sufficient, whereas in this case, 4 cylinders, that is in Prius and hybrid. And engine power varies from 67 to 76, although both are using batteries. And the electric motor power is 67 was here and 13 is here. So it total is about 80 horsepower, whereas here it is 98 horsepower and here it is much more than 140 horsepower. So these are the options with Honda. Those days, these were available in 2008 and 9. And batteries used were nickel molybdenum hydride in all these cars, and mileage possible was per gallon 60 miles in case of Insight, and Civic Hybrid 46 miles and Prius 60 miles. And on freeway, this mileage is more. And if we compare, and figure for the acceleration is 11 seconds from 0 to 60 miles per hour. And if we compare the hybrid mode and non-hybrid mode, if we compare the Civic, same vehicle in hybrid mode and non-hybrid mode, we see the engine capacity is more in case of regular mode, that is about 1600 cc, 4 cylinders, whereas in hybrid mode, only 1300 cc engine is sufficient for giving you the similar identical performance. And you are benefited when you use electricity. You get 46 miles per gallon as compared to 32 miles per gallon of gasoline used in non-hybrid vehicle. So these are the advantages of hybrid in these cars. However, a lot of work is required in these cars further to put it on road so that we are able to use frequently. That is, apart from fuel economy and low emission, advantages of hybrid electric vehicle is first development efforts on. A lot of efforts are required further on development of permanent magnet motor and controls. But once we succeed with this, we'll be happy and we'll be able to use fuel cell vehicles, and that will be their debut in future. We'll be seeing a large number of vehicles with fuel cells if we succeed in this permanent magnet motor and controls. Some work, whatever was done by DRDO in my time, I'd like to share with you. That we worked on 3 vehicles. There is parallel hybrid on 1-ton Tata chassis Ace and Swaraj Mazda bus. This was a diesel engine. We converted into hybrid mode. This was a Swaraj Mazda bus, also diesel engine, converted into hybrid mode. And then we also developed a fuel cell in one of the laboratories and used for extending the range of Riva car. Here what you see is a prototype of parallel hybrid vehicle on Tata Ace, this platform. This chassis used to be most popular in my time, and this is the highest selling vehicle of the Tata Motors. Still today also, this is in great demand. And we converted into hybrid mode, parallel hybrid. We see the specifications of the vehicle. It uses a normal diesel engine of 700 cc developing 11 kilowatt at 3200 RPM. We converted into hybrid mode by using electric motor of 8 kilowatt, 3-phase AC, and maximum speed of the motor being 8000 RPM. With this, we succeeded in converting the vehicle into hybrid mode, and it is being run in VRD, I hope, and the range of vehicle is 80 kilometers. Its electrical system is 72 volt incorporated in the hybrid vehicle. A three-phase AC induction motor, controller, batteries, and other electric accessories are integrated into the vehicle for electric operation. 5 different modes of operation are possible in the state-of-art developed parallel hybrid electric vehicle. These modes are engine-only mode for highway application, electric-only mode, city and silent application, hybrid power mode, gradient climbing and high power zone, online charging, that is for charging of batteries during cruising the vehicle. This is another Swaraj Mazda bus, also converted into hybrid operation by use of brushless DC motor. Pulse width modulator was added and batteries were also added with auxiliary engine of a smaller size. And here you see the series hybrid bus Swaraj Mazda. 2 power sources, lead acid battery and IC engine. Motor directly coupled with the wheels through conventional automotive transmission. Driven and controlled by electronic system. Pulse width modulator. This is the luggage compartment which has been used for storing the batteries of the vehicle. And this is the diesel engine of a smaller size, that is only 45 horsepower engine used in the diesel engine used in the Swaraj Mazda, whereas the original engine was of 70 horsepower or so. So we could reduce the size of the diesel engine for converting into hybrid mode. Here you see the Riva car, which is quite popular in Bangalore, being manufactured for so many years, but is still in a limited stage. Similarly, all the electric vehicles are being used in a limited manner. Like off-road vehicles, we see electric vehicles in campus, hospitals, airports, universities. And on-road vehicles, we see two-wheelers, three-wheelers, cars is Riva. So this car has specifications, the 2-door hatchback. 4 persons can travel in this at a top speed of 65 kilometers per hour. It was integrated with power system, motor of 13 kilowatt, controller of 400 amperes, and a charger of 2.2 kilowatt, and power pack of 48 volt, 200 ampere hour. Electrical vehicle tubular lead acid batteries were used as in the original vehicle, and this weight of this vehicle is about gross weight is 670 kg. So now there is a lab. So limitations of this vehicle are range. Battery technology maintenance is another problem, and weight and initial cost is also the problem. So to overcome these problems, NMRL cell developed. NMRL is a laboratory in Ambernath, Bombay. That is Naval Materials Research Laboratory. They developed a fuel cell for use on this car. That is an electrochemical device, uses electrolyte system, and it is free from noise, vibration, and pollution. Produces DC power as long as fuel and oxidant are supplied. Operates on process and not on cycle. The high efficiency of 85% and electrochemical cells. Chemical energy of fuel from hydrogen, methanol, and methane continuously gets converted into electrical energy using atmospheric oxygen. Conventional fuels must first be converted into hydrogen in a chemical gas reforming reaction. Most important application for generating electric energy in spacecraft, and submarines. These fuel cells are already being used in spacecraft and submarines, and it can operate on variety of fuels. So this fuel cell was developed out of, there are different types of fuel cells, different technologies are there. So out of this, phosphoric acid was based fuel cell was developed. I'll show you the specifications. Here we see different types of fuel cells with having different electrolytes, operating at different temperatures and having different cell efficiency and have different applications. So out of this fuel cell of phosphoric acid type was developed with 700 to 1000 watt capacity, with generator with built-in compact methanol reformer, and it delivered 220 volt AC at 700 to 1000 volt ampere. So power output was 8 kilowatt of this total unit, and PFC uses hydrogen and air. There were 6 stacks of 1.5 kilowatt each. This, what you see, the stack is of 1.5 kilowatt, and there were 6 developed for use on Riva car and housed in this cabinet. And the output was 12 volt DC and maximum up to 100 watt. Hydrogen source by hydride cracking was obtained, and then fuel cell helped to increase the range of the electric vehicle. And this fuel cell vehicle was displayed in the Defense Expo of Delhi, that is the year in 2009. Thus, the DRDO developed this fuel cell battery hybrid vehicle on an electric vehicle platform, thereby reducing the problem of limited range of vehicle through onboard charging of the batteries by fuel cell. Thus, fuel cell is acting as a range extender for the electric vehicle. This is also a small car developed by Delhi College of Engineering students, the students project, where they converted a Mahindra platform with diesel single-cylinder air-cooled engine of 346 cc and used electric motor on this of 3.5 HP and converted into hybrid mode. So this kind of project can be taken up by your students to further improve it, because this has not come to the market. So must be a lot of problems must be there. So the students can look for working on this kind of project. This is another small two-wheeler which was manufactured in Gujarat, in Ahmedabad, and it was very popular in those days, 2008 and 9. But for the problems of charging the batteries, the battery operated two-wheeler, for charging the batteries, this and company was closed. There are companies which can supply you the components for converting the vehicle automobile into hybrid mode. There is one in the Deltec Chennai. They have the technologies for motor and drive controls for AC, permanent magnet synchronous motors, technology for switch reluctance motors, also available. Patented technology in US, they have patented it. And this was also going on in my time for patenting in India. Now I am not sure of the current status. Software-based intelligent controls can network with other electronic systems. Can bus architecture be provided if needed? So if you have to convert a vehicle into hybrid mode, you can look for these systems from this company. They have permanent magnet synchronous motor controls with output supply ranging from 115 to 230 volt and power rating of 10 from 50 to 10 kilowatts, 50 watts to 10 kilowatts, and controlled technique being space vector permanent pulse width modulator embedded in the processor. Integrated power module designed for controller, they were also working. Their technologies are conforming to statutory regulations, that is EMI, EMC, and safety regulations, life, endurance life, and environmental specifications also are met by their